So this is Calico community meeting for April 14th, 2021. Chris, I think you volunteered to take notes in advance, so thank you for that. I'll share the minutes doc in the chat in case anybody wants to help Chris out on that. Should have access. And I'll get us kicked off with just some updates. So the big thing on my mind is Calico 3.19. I think last time we all spoke, we said we were aiming for a release of that in mid-April, which is now. It is now mid-April. We are still looking like we'll probably have it this month, although we've had a few delays to that initial schedule. So I think we said we were hoping for the week of the 12th. We're looking more like late in the week of the 19th at the moment, or early in the week of the 26th, just depending on how the last bits of development and testing go. So to recap what we're working on there, we've got some really cool tech preview features that are in progress. So VPP data plane being one of those, and I'll ask Nathan or Eloise for a quick update on that in a little bit. We've also got support for the new Kubernetes network policy endport field, which is, I believe, beta upstream. So thanks for Matt and Ricardo for showing up, because you guys did a lot of work on that. And we've also got a tech preview feature to remove dependence on the Calico Cuddle CLI tool. So moving a lot of that defaulting and validation into a place in the Kubernetes API server, so that folks can just use kubectl to manipulate all these things. So all of those are really exciting. We've also got a few other things coming. So some changes to make Calico node run as non-privileged, which is the first step in towards our ultimate goal of getting it as non-root. And for the Windows data plane, we're introducing containerd support to the CNI plugin. So that's also very timely, as Docker shim is being deprecated. I think those are the main things in 3.19. There's obviously a bunch of other smaller bug fixes and stuff, but those are the kind of things I'm most excited about. Maybe I see we've got Lance on as well, so that's great. Maybe Lance and Nathan and Eloise can all chat about where we're at with the VPP progress.
Sure. Hey everyone. So we've been quite busy on VPP the last 2 weeks, trying to get it in a more stable state for the tech preview integration. So we've made a few changes. Most notable ones will be on the deployment model. We've split the VPP data plane to a separate daemon set that lives next to the regular Calico node daemon set. And also we've had to change the network model for the way we provide the connectivity to the host when we use VPP. So now, instead of creating a TUN interface named VPP tab 0, we actually create a TAP layer 2 interface. And that uses the original interface name. So the drawback is it's a bit harder to know you're running the VPP data plane, but the benefit is it integrates way better with all the network managers and the systemd networkd processes. And yeah, other than that, quite a few bug fixes that will allow it to run better on Google Cloud and Amazon and EKS.
And we're also looking at some improvements there, but they might come a bit after the so maybe not for the release, but for example, on AKS, we now support DPDK sort of out of the box, even if it requires a bit of work there, compiling kernel modules and stuff, which is not quite easy. But there is pending work for having the interrupt mode, and we're also looking at not depending on IGB UIO, and maybe resorting to a VFIO, modified VFIO to have write combining for performance reasons. So we are there are still a few things to improve there.
Thanks, guys. I know Lance has been doing a bunch of validation and testing on that, and even working pretty close with him. So, Lance, I don't know if there's anything you want to say, or
I think it's all been covered.
Yep. Cool.
Nathan, can I just clarify, was that AKS, the DPDK support, or EKS?
EKS. So EKS by default, it doesn't have, so it has a kernel with a version of 4.14, I think. So it does not support the AFXDP to consume the file. So we default to AF packets, but using DPDK would provide a bit better performance. But the issue with it is that by default, AWS doesn't enable write. No, it enables write combining by default. So basically, it's optimized towards latency and not throughput, and that brings some performance issues. So in order to consume it and have good performance in DPDK, we need to have a special kernel driver for that. That's why we needed to insert a special driver and to be a bit careful about this. Also, because of when using DPDK, you might end up with no interface at all. So we might want to be extra careful with that and not end up with AWS instances dangling in the void, which has proven a bit tricky. But yeah, it was EKS. We haven't tested with so Calico plus VPP with Azure yet.
Thanks, Nathan.
Thanks, guys. Any other questions for Nathan or Eloise? If not, Eric, do you have anything for us today?
Yeah, for the operator, not much. Just one thing. With the 319 release, the operator will now support some additional configuration for the BPF data plane. There's kind of some, you could enable it before through Felix config, but there was kind of a piece that wasn't there in a volume mount, and now there's a new field in the installation configuration for the operator that will add that volume mount and switch Felix into BPF mode. To be clear, if you're using BPF, you should be configuring it with the operator. But yeah, I think that was the only thing I had for this meeting.
Yeah. So only if you're using BPF and the operator. So if you're installing with a manifest, then you can turn on BPF using Felix config. But if you are using the operator, you must use the operator config, or you won't get the volume mounts, and then things won't work.
I think we've spoken about this before, Eloise, but that's the same config PR base that I think will be useful for the the VPP data plane as well. On the topic of operator, I think the only other thing that was on my mind, we did get a PR through to have the upstream EKS manifests that are provided by Amazon. They now use an operator-based install method. So that's one more domino in in the path to operator world domination. It's inevitable. Any other check-ins or things that updates folks wanted to give? I think that was all on my list, but I certainly could have missed something. If not, I've got a couple issues I wanted to bring to attention here. So I've been doing a bunch of code reading of the CRI-0 code base recently for various reasons, and I found some issues with it that impact Calico. So got some links I can stick in the chat for you. Right there. So yeah, there's some issues in Cryo around CNI teardown being called in different scenarios. Details are all in those issues, but the long and short of it is that Cryo is not calling the CNI plugin to tear down networking in a few different occasions. One of them, the more serious of the two, is on node reboot. So it kind of forgets about all of the containers that were previously running there and doesn't ever call teardown on them, which means if your CNI plugin stores any sort of state associated with those containers, that state will get leaked. So with Calico, and I assume some other plugins as well, this usually shows up as leaking IP addresses. But if your CNI plugin also stored some other sort of state, you know, in a non-volatile way tied to the node, then that would also be leaked. And the Cryo maintainers have confirmed that this is a problem. The other slightly less serious issues are really more in a code path related to resource contention. So when nodes are overworked, they have some fancy logic to help reduce some of the you know, extra burden that might come from retrying CNI add calls. So they do some caching and retrying or not retrying, even though they may be asked to retry. But that logic has a couple issues that cause problems. So if your node's overloaded, then you're probably also going to start seeing CNI del requests not happen. Yeah, so the main thing here is that Cryo is the default and I think only runtime supported on OpenShift. So if you're using those platforms, be aware and make sure you're draining your nodes before restarting them as one, you know, mitigation approach here. Don't know a timeline for a fix, but I know the maintainer is looking at it. So that was all I had. Any Anybody else have any issues to discuss?
I had one when you're using a non-Calico CNI with Calico. The termination grace period wasn't being honored, so we'd unnetwork a pod as soon as it was, or we'd block traffic to a pod as soon as it was terminated. So that was one fix went in a few weeks ago, so that should be in 3.19.
Cool, yeah, I remember seeing that go by. That's a good one. So I wanted to give a couple shout outs to both Ricardo and Matt, who are here on the call. They've been doing a bunch of work upstream in Kubernetes around network policy, and some of that has, of course, trickled into Calico as well. So I found, well, Ricardo has added support for this new, and he corrected me, alpha feature in Kubernetes to support port ranges using a new endport field. And I wanted to thank Ricardo for doing a bunch of work to get that working in Calico. So that's exciting, and that'll be, like I said earlier, in 3.19. And I wanted to thank Matt for both finding and fixing a bug in Calico around our parsing of empty port structs in network policy, which we were not handling correctly. So thank you guys.
I think endport, it's been a long time coming. Like, we've certainly had customers who've like rolled their own version of that and put 64,000 ports in one rule, which doesn't work particularly well.
No,
Much better to have a range.
Yeah, I remember seeing somebody make a policy that was so large. It was like, I think it was either getting rejected or truncated by etcd or the Kubernetes API server or something. It was very weird. They had so many rules in their policy that it like bypassed the size limit for a single object.
Yeah, this affected me in my previous role directly, actually. So Ricardo, thank you so much. We ended up using for loops in Bash to make sure that we didn't miss any port numbers, because if you copy and paste, then you can lose it. So yeah, thanks, man.
So I think, sorry, go ahead, somebody.
Yeah, thanks. Would like to give a quick shout out to Lance Robson as well for dealing with all the Calico VPP data plane tests. It's not easy. He's finding all the bugs everywhere, but it's really super helpful. So thanks a lot.
No worries, it's been fun.
Lance gets some sort of
perverse pleasure,
primal,
I think is what you're looking for.
Perverse pleasure is the word I'm looking for in breaking things. I know all too well. So I think Matt is here with a demo for us about some of the new testing tools that actually helped find this empty port parsing issue. So Matt, if you want to take it away, it's all yours.
Sure, yeah. Can I share my screen?
You should be able to, yeah.
Oh wait, you cannot start screen share. Wait, let me try again.
Oh yeah, sorry, somebody else was sharing.
All right, cool. All right, yeah, well, that's getting set up. Hey, everybody. I know a couple of you, Chris and Sean, but I guess most of y'all I'm meeting for the first time. So nice to meet you. All right, cool. Yeah, so I want to just give you a brief demo of Cyclonus. I don't know if you've heard of that before, but I'll show you that. I'll tell you a little bit about history, where we might be going possibly, and hopefully this will all fit in about 10 minutes or so. So we'll see how it goes. All right, cool. Yeah, so just want to do a shout out for the network policy sub project. There's a lot of people who have been coming from different CNIs and working on network policies together, looking at how to improve the API and stuff like that. So a lot of people there have heard of Cyclonus before, and a lot of ideas that are coming out of that are going into Cyclonus. Cool, yeah. So the history of Cyclonus is it came out of the upstream E2E network policy tests, which I'll show you a little bit more of like what we're doing there that's different. I think we merged that in January, and it was a much more comprehensive way to test whether your CNI is doing the right thing or not, with like 20 or 30 different specific network policies. So Cyclonus is kind of the next step in that pathway. And right now, the basic goals of Cyclonus is kind of twofold. So the one that we've sort of been hitting recently is just doing humongous test batches of network policies, doing all kinds of different things, whatever you can do with network policies, whether you're talking about things like ports and protocols and soon port ranges, like we were just talking about, monkeying around with like creating and deleting network policies and labels off of pods and namespaces, and just running huge batches of those tests and seeing, like what CNIs do and kind of measuring that stuff and finding bugs, reporting those and fixing those and things like that. So that's kind of the like automated high volume side. And then the other side is, which I don't know, not a whole lot of people have been looking at the other part is, as you all know, network policies have a pretty complicated API. It's really hard to think about what they're doing and whether traffic is going to be allowed or denied, because there's like the isolation rule, and then the implicit allow if you don't have anything targeted, but then if you do have it targeted, then it's a deny unless there's an allow, and how all of those policies on top of each other can make things tough. So I have a crew plugin that's built out of Cyclonus that you can use to just point at your cluster, analyze the network policies for you, and help you to understand better what those things actually do, and they're all sort of like combined together without having to actually set up pods and have communication go back and forth. So that's kind of the twofold goals of Cyclonus, but basically it's around helping people to use network policies and understand the network policies and make sure that everything's working the way they want it to work. Oh, let me share this link with you. So, I guess I'll share it afterwards. Cool, yeah. So the Cyclonus secret sauce, in case you're wondering, is that we have a policy engine where you can tell it what's in your cluster, like what the namespaces are, the pods are, or you can just have it read it directly from your cluster. And then based on the labels that you have and the policies that are in place, it will be able to decide whether a pod can talk to another pod. And so what we do is we spin up a whole bunch of pods. I'll show you this in just a second, so it'll be a lot more concrete. Basically, we spin up pods. We collect actual connectivity data using kube control exec to send requests from one pod to another. And then we just see if that matches what we expect to happen from the policy engine. So let me take you over to a Cyclonus test run. By the way, if anybody has any questions, feel free to interrupt. All right, cool. So this is over on the Cyclonus repo, and I just stole some really cool ideas that I saw in other places where you can spin up kind clusters and GitHub Actions, and then put CNIs, in those kind clusters, and then run things. So I know that this isn't probably the most realistic infra out there, And, apologies for that, but it's kind of cool and fun, and it's a lot cheaper than, than paying GKE or something like that.
We have a lot of tests based on kind in our repos. It's not a bad thing to use to test Calico.
Yeah, awesome. Yeah, like maybe a good first pass. Maybe it's not like 100%, but hopefully it's like 99 or something. Yeah, cool. All right, so what we do in the typical test case for Cyclonus is we start off and we spin up typically 9 pods. So 3 namespaces. You can see I have namespace X here, pod A, pod B, pod C. And we label the namespaces with a unique label. We label the pods with a unique label. And in each of the pods, we run on multiple ports and on multiple protocols. We're just using AGN host, if you're familiar with that, because it can serve TCP, it can serve UDP, it can serve SCTP. It can also be the client side for those things as well, and avoids the problems of, like, with UDP, we initially had a problem where, like, even if something was blocked, I guess if you're not careful with how you issue UDP requests, you might think that it succeeds or something like that. But AGN host has something built in to avoid that kind of problem. So you can see that we have port 80 and port 81, and then we have a named port for those that we can target as well for network policies. All right, so namespace X, namespace Y, same thing, pod A, B, C, and namespace Z. And we also have a service that targets each pod. So the reason that we do all this setup is now we can think about network policies, like which pods do they target? Are you talking about ingress, talking about egress? Since we're not just talking about one pod to another pod, we're talking about a whole matrix of connectivity, which I'll show you in just a second. All right, cool. So this case, or this test run was going to run like 100 cases. So it's just listing out all the cases here, trying to hit all kinds of different corner cases with IP addresses, ports, protocols, multiple rules, denials, allowals, all that kind of stuff. It's not 100% comprehensive, but it does cover a decent amount of stuff. And let's get down to the first test case. All right, so the first test case is this network policy here. And wow, that's a huge policy. It doesn't even fit on the screen. Let's just look at the table. So this table is, wow, this doesn't fit on the screen either. All right, sorry about that. Basically, we have the 9 pods going down the left side as sources, and 9 pods going across the right as destinations. So that's 9 by 9. We have 81 data points here. And then we also do requests across each protocol and each port that we have open. So 6 times 80 is like 480 requests here. And you can see that we're issuing a request, from pod XA to pod XC over this first one up here would be SCTP 80. And an X means that it's blocked, a dot means that it's allowed. So this test case passed because it's Calico, and you guys pretty much passed all the test cases that we can ever think of, which is awesome. So this is both the expected and the measured connectivity. So you can see that the real really cool thing about the upstream E2E tests was when we started doing these tables, when you looked at a table and you saw what was allowed and what wasn't allowed, it became a lot more clear if things were working properly. Like it gives you that eyeball, you can eyeball a matrix and be like, oh, okay, I kind of see what's going on, or what's working or not working. All right, yeah, so we have 100 some test cases. So basically we just go through, we calculate these tables for what we expect. We do kube control exec for 500 data points and compare that to what we expected, and do that a whole bunch of times, and then down at the bottom tabulate all that stuff. So this is from a couple of weeks ago. There were a couple bugs, a couple super minor bugs that we found and I think have been fixed. I don't have the latest results, but basically what we're trying to do is take these 100 odd tests that we have and look at the different features that were present in each of those in each of those tests and just break it down by like what was working, what wasn't working. Obviously, it's kind of tough to figure out like what the root cause is from this kind of thing, but this just sort of gives an indication of like, IP blocks are working, right? But named port, maybe there's a potential problem there with named ports. Now, I think there was actually a slight thing about named ports, and a slight thing about SCTP.
It was SCTP named ports were broken.
Okay, yeah, perfect. Yeah.
So your input data, presumably like you're handcrafting the network policy and then tagging it with these labels so it pops out at the end. Is that how it works, or is it generated network policy? Or
yeah, we do have some capabilities for generating based on some rules and stuff like that, but we haven't explored that too much. So it's definitely something that we could do without a huge push, without a huge lift, but isn't quite. Yeah, so right now this is just a canned set of 100 and you can run it over and over and over. If that's, if the fuzzing kind of idea is valuable to you, then I would definitely love to explore that some more. All right, cool. Yeah, so just wanted to, we kind of touched on these a little bit, but this was something that I found with Cyclonus, and that was really cool for me to hop into Calico and fix it. And Sean, I'm not sure, but I think this was also found with Cyclonus, right? And then this one was the one that you fixed.
Yeah, exactly. So it turned out that we had done all the work in Felix, our kind of central daemon, to implement SCTP named ports, which, like kind of based on the work we'd done for TCP and UDP. And then there was just a tiny link in the chain where we'd forgotten to copy the named port from a pod definition to like our internal data model. So we'd done all the work to implement it and tested it thoroughly at FV level, and we were missing we must not be running an E2E that hits this case. But now, like your tests that you've added to the E2Es obviously hit this case, so we should be running those.
Yeah, awesome. Yeah, that's cool. Yeah, happy to help out there. All right, yeah, so I'm pretty much done. I just want to wrap this up real quick. As far as future Cyclonus, things like there's a lot of stuff that we still haven't really scratched the surface of yet, like IPv6. We haven't tried any CNIs against that yet. I was trying to do this with Kind, but I couldn't quite figure that out. So if anybody would be interested in helping me figure that out, that'd be super cool. But just like trying to expand the scope of where we're running our tests. Dual stack would be another one. I'm sure there's a lot of other things. Collaborations and stuff like that. I don't know if anybody has ideas for how to leverage the Cyclonus stuff or do something cool with it. Always happy to chat about whatever. Let's see. I mentioned SIG network policy before, so we want to work with CNIs to just do the whole like standards conformant implementation kind of thing, and help people who are using CNIs to know that there's like a the Kubernetes subset of network policies is going to be consistent from CNI to CNI. And there's also some work going on to add more things like port ranges. And I think we have default namespace labels coming down the pipe, maybe cluster network policies, like whatever is coming down the pipe for future versions of the network policy API, just try and support those efforts to get that stuff like understood and tested and, out to everybody. And just wanted to thank a whole bunch of people that have worked on this and, been really influential in this stuff. So you can see all their names here. All right, yeah, that's all I got for everybody. I'm happy to take any questions, either online or offline. I probably took up a little bit more time from this meeting than was the plan.
No, you're fine. That was great. Thanks, Matt. It's more of a comment than a question, but the dual stack thing, I think I can see there being a lot of value in comparing v6 and v4 address families and making sure that the same rules. I can see as if I was back in my old role, making sure that I had the same set of functionality in v6 that I had in v4 and vice versa would be quite helpful.
Yeah, that'd be cool. Yeah, if anybody knows like how to set up
Pretty sure
Calico
we
with
run,
like a
Lance, don't we run dual stack IPv6 on kind?
Yes, we do.
Some test suite.
Yeah,
So
I'd be happy to take a look at what problem you're having.
Yeah, that'd be awesome if I could just take a look at that. Cool. Yeah, I'll reach out.
Cool.
That was Lance, right? Lance R.
Yes.
All right, awesome.
Yeah, thanks a lot, Matt. This is very cool. I don't think we have it yet, but I'd love to see this running as part of our like per pull request CI in some way, just to catch these little things. Is there any way? I noticed it. I mean, it's very comprehensive, and there's some fundamental limit to the amount of time it takes to like spin up a pod and run some connections and tear them down. Is there any way to like run a subset of these tests if we wanted to do, say, like a shorter smoke test on a pull request and then run the full thing against?
Yeah, so with the tests being tagged with different features, there's ways to exclude and include. So you can, like, if you just want to, the typical subset that I do is where I try and make a bunch of conflicts between, say, allow by IP and block by, like label or something like that. I feel like those do a pretty good job of being representative, and it's like 1/10 of the test suite. So, it runs a lot quicker. Or you can even parse it down further, just a couple tests based on that. So yeah, there's just command line args that you can give to Cyclonus to do that kind of thing.
Nice.
Cool. Well, thanks everybody. Appreciate it. The opportunity to talk about that.
Hey,
yeah, thanks for sharing that, Matt.
Thank you.
Yep.
Matthew,
like
I had to step away at one point. Did you actually run Cyclone? Like how long does it take to run? I is my question.
Yeah, it seems like on Kind and GitHub Actions, we have about 110 tests. Most of them are like one step, but a couple of them are like create a policy, do it. Collecting data is what takes a long time, basically. So there's a few that are a couple steps, and it's about an hour and a half or so. So okay. What's that? Maybe like a minute or so per test.
Okay, cool. Thanks.
But if you compare that to the old way of doing E2Es, like each one of those X's or dots in the matrix there used to be a separate E2E that would take 30 seconds, pretty much. Like you'd end up having like an E2E that tests this port to that workload with these labels and this policy, and you don't get the coverage of like a matrix of 400 different connections in the old E2Es, not the ones that you guys added, but the really old ones. It's really cool.
Have you considered dropping the character to use some kind of half-height ASCII character to squeeze in the matrix into a smaller space?
That would be a good idea, yeah. But I'm a developer, so those visual things just yeah, I would love that. If you can like write that down or something.
Yeah, the trouble is I want to volunteer for it right at this moment. I don't want to volunteer and not deliver, but it should be doable.
Yeah.
It occurred to me you could put the symbols like side by side in the box, because you've got like then it would be like 6 characters wide instead of 6 lines tall in each box.
Yeah, that's a good point.
That might sort of trim it right down. Now you've got SCTP and stuff in there as well.
Yeah.
It feels really nice to get the matrix on one page, doesn't it? It shouldn't matter, but it does feel nicer when it is.
Yeah, no, I agree, definitely.
You guys don't have 4-foot tall monitors at home? Cool.
Yeah, we zoom out behind Matt and find he's just got an ultra wide, but in portrait mode, and that's how he rolls.
Yeah, that'd be cool. Just all day long, just like looking at these network policy matrices.
If there are no other questions for Matt, we could open it up to any other more general questions or topics of chat, but we're at the end of the agenda. All right, I guess that's all. Thank you.
I could just state really quickly, Katie, I'm maintaining a sheet of things that I'm picking up that people would like to see from Calico users and from LinkedIn and anywhere else I see comments really. So if anyone does have anything that they would like to share either now or offline, feel free to hit me with it. And I can't promise immediate action, but I can promise it will be noted.
Did you catch my running Cyclonus as part of our purple request CI? That one's...
Yeah, I think that's in there already. Yeah.
Nice. Cool. Well, I'll see most of you guys on the internet, and we've got the next meeting. What is this? April? So May. Second Wednesday of May, which looks like the 12th. Thanks, everybody.
See you guys.
See you later.
See ya.